Alright guys, it's Mr. Gron, and back in my garage doing a video now. We're back from the hospital, and baby and mama are doing okay, so I'm going to be making a couple of videos in my garage for you guys to watch and hopefully learn from. Today is first day of 11.3, which is independent and dependent events. So every situation that we can calculate a probability, it's a probability of an event. And so we've got dependent and independent events. Our objectives today, determining if these events are independent or dependent, and then finding their probabilities. Our first vocab is OR, a word we all know and love. These events are going to be either and or statements. If you see an or statement, that's going to mean that you need to add. For example, the probability of rolling a 1 or a 2. What I'm going to do with this is I'm going to say, if I'm rolling a single die, my probability of rolling a 1 is 1 out of 6. Probability of rolling a 2 is also 1 out of 6. So if I add those two together, that's going to be 2 out of 6, and that would reduce to 1/3. So that's our OR statement. Okay, our second situation would be an AND statement. If you have an AND statement, you're going to multiply. An example of that would be the probability of rolling a 1 and then another 1. So in that case, our probability of rolling, our first one is 1/6, and then probability of rolling our second one is another 1/6. Now, multiplying fractions, we should know how to do this by now. Multiply across the top, across the bottom. We're not adding across the top, bottom, that sort of thing. So this is going to be 1 on the top and then 36 on the bottom. And that kind of makes sense too, right? We've had those dice charts that had all the possibilities, and there was only 1 out of the 36 that had a 1 and then another 1. Okay, so within AND statements, this is where we get our independent, dependent events and kind of what the difference is between them. With an independent event, the outcome of the first event does not affect the probability of the second. So for example, if you flip a coin once and it lands on heads, and then the second time landing on tails. These are independent of one another. Just because I flipped a coin and it landed heads does not affect the probability of that second outcome. So then, what's the probability of this happening? It's an AND, so we're going to multiply. Probability of heads would be 1/2, and then times probability of tails would be another 1/2. Multiply those, and it's 1/4. Alright, so our dependent event then is when the outcome of the first event affects the probability of the second event. For example, drawing an ace from a deck of cards, then drawing another ace without replacement. Now that's something you're going to hear in this unit, is drawing with replacement, drawing without replacement. What that means in this case without replacement is I drew an ace out of the deck of cards, then I didn't put that card back, and I drew another card. So now there's one less card in the deck for that second draw. If I said with replacement, this would be an independent event because I draw the ace, then I put it back, maybe shuffle the cards up, and then draw another one. So there's the same number of aces, there's the same number of cards for the second event. But in this case, when we don't replace it, there are 4 aces in a deck of cards. So that is going to be 4 of the 52 total. We're going to multiply again because it's an AND statement. Now that I've drawn 1 ace out, there are now 3 aces left, and there are 51 total cards left. So now when I multiply those, 4 times 3 is 12. 52 times 51 is 2,652, and this would reduce, and this reduces down to 1/221. Now, when you get to the quiz, I think it probably will allow you to do it as a decimal. Just make sure you're rounding correctly. It might say to the nearest hundredth. So just 12 divided by 2652 and give me the decimal version of that. All right, so our last thing is conditional probability. What conditional probability is probability of an event with the condition that something else has already happened. So the probability of the second event given the first event actually did occur. So for example, if we go back to the drawing an ace example, the probability of drawing an ace given an ace has already been drawn. So the probability of that first ace being drawn we figured out was 4 out of 52, right? So our first ace, that was a 4 out of 52. And then so the probability of that second ace, given that we already drew the first ace, is now 3 out of 51. So that would be our conditional probability for drawing that second ace. Okay, so for the first example, what is the probability of rolling a sum of 3 or a sum of 11? And I've got our dice chart up here. This is what we're talking about. This is an OR statement, so we're going to add the probabilities here. This probability of rolling a 3, well, I've got, or a sum of 3, I've got 2 possibilities out of the 36. So that's going to be 2 out of 36 for rolling a sum of 3. And then probability of rolling an 11, that's 2 of them as well, 6 and 5 and 5 and 6. So that's another 2 out of 36. When you add those, that's 4 out of 36, which would reduce to 1/9. Would reduce to 1/9. Again, what we're really doing here is we're saying what's the probability of one or another. So another way people might look at this, especially with the dice ones, is they'd say, well, what's the probability of rolling a sum of 3 or 11? Well, I've got 1, 2, 3, 4 possibilities out of the 36, and then figuring it out from there. This is a little more of a drawn out way, kind of the oversimplified way. Now, Daddy's teaching now. Okay, so our second example, now some independent, dependent events. Rolling a 6 and another 6. It's an AND statement, so this is multiplying. It's either going to be a dependent or independent. Rolling a 6 and then another 6. Rolling the first 6 doesn't have anything to do with me rolling that second 6, so this is an independent event. Let's see. So rolling that first 6 is a 1 out of 6. And then multiplying, rolling the other 6 is also 1 out of 6. So that's going to be 1 out of 36. Now I left the dice chart up here for this one. This is one way to do it. This is the multiplication way. Some of these you're going to have to multiply. Some of them you can kind of work it out just kind of mentally. Rolling a 6 and then another 6, well that's 2 6s, and that's 1 out of the 36 possibilities from our dice chart. So that's another way you could do it as well. Then flipping a coin 3 times and it landing heads, and then tails. This again is an independent event because, whatever I flip the first time doesn't have any effect on it the next time or the next time or the next time. So our probability of flipping and landing on heads, the first time is 1/2, the second time is another 1/2, and then the third time landing tails is another 1/2. So that's going to be 1 times 1 times 1 on top is 1, and then 2 times 2 times 2 on the bottom is 8. So a probability of 1 in 8. Okay, our last example, our third one, we've got our red and blue die problem. We're rolling red and blue dice. The red die is 6 and the sum is greater than 9. Or is this an independent or a dependent event, and then what is the probability? This is actually going to be a dependent event. This is one that a lot of people, at first, they think it's independent because most dice problems are. But the reason that this is dependent is that if that first die is not a 6, that for the red die is not a 6, it's going to change the number of outcomes where the sum is greater than 9. Okay? So one way I can do this, that, you know, if that first one was like a 4, then if the red one was a 4, then it's going to be a different probability of the sum being greater than 9. If the red one was a 5, it's again going to be a different probability of the sum being greater than 9. Because the higher that red one is, the more, you know, possible ways there are to make a sum greater than 9. If the red one was a 1, for instance, like there's 0 ways that it could happen, versus the red one being a 6, there's more ways. So we'll take a look at that in a second. Now, what is the probability that the first roll, the red one is a 6? Well, that's 1 out of 6. Now that we've rolled that first 6, our probability of getting a sum greater than 9, well, if I look at just where the sum is 6 here, this bottom row, or where the red one is 6, excuse me, that bottom row, I've got 1, 2, 3, where the sum is greater than 9 out of the 6 possible. So that's going to be a 3 out of 6. And when you multiply these together, that would be a 3 out of 36, which reduces to 1 out of 12. 1 out of 12 for that one. Now, another way that you could do this one again with the dice one is just looking at the dice chart and saying which possibilities here meet both of these, where the red is a 6 and the sum is greater than 9. And that's going to be just these 3 right here, and that's 3 out of 36. Now, some of these, you know, you're not going to have the, you know, they're not going to be dice related ones, so it's going to be a little bit different. But take a look at the homework. I'll throw that up in here in a second, but I'll post a key to it either today or tomorrow, and so you guys can kind of check your work as you go, because I'm not going to be there, obviously. And so yeah. One last thing about this one, why it's dependent versus independent. The red die is a 6 and the sum is greater than 9. Again, earlier I'd said, well, if the red die was a 5, it would be a different probability, right? So if it's the 5 row, now I only have 2 out of 2 possibilities. If it was 4, I only have 1 possibility. If it was 3, 2, or 1, now I've got 0 possibilities. So that first outcome affects the probability of the second. That's why this is dependent. All right, now your favorite part, the homework. Page 815, 2 through 4, 8 through 13, 17 through 23, and it'll be on the calendar. All of the book pages on Canvas like usual, and like I say, I'll put together a key so you can kind of check your work, and you know, I'll see you guys on Tuesday.